Could you talk a little bit about Fusaka and or Amsterdam and or the path forward in terms of these upgrades?
Yeah. Yeah, I spoke about Amsterdam because it has like a bit more of these scaling VL1 features, but Fusaka is actually like a super, super important feature for scaling blobs, which is called PeerDAS. So DAS stands for Data Availability Sampling. Um, so in short, this should allow us to 8x the number of blobs that are currently provided by the network. So today we have this target of 6 blobs. With PeerDAS, we in theory can achieve 48 blobs target, so 8x the capacity of the current network, which is like almost an order of magnitude improvement over like the status quo, which is really significant. I can go briefly into how that works. Today, every node gets every blob in full. With PeerDAS, the idea is that we take a blob, split it into 8 pieces, and nodes only have to store 1/8 of the blob. And so that gives you like that 8x factor for the network as a whole to scale the number of blobs. And the network as a whole can be convinced that the blobs are indeed available because there's like these checks on the network for these parts of blobs, like making sure that everybody's convinced that the blobs actually exist and are available.
Could you actually just provide a little bit of more context on the, let's say, the constraints of doing that? Because, so first of all, like when you have only 1/8 of the blob, like, is this random or, basically like there's a statistical component to kind of what you're describing. And I'm kind of
Yeah.
curious to understand, first of all, there's even like, okay, so why now? What happened recently that suddenly this is, something you could do now? But I think it'll ultimately get into, maybe you could provide a little more detail on kind of how that 1/8 is selected. And then, for instance, if I'm going to challenge some state transition from a roll up, kind of the mechanics of how that would actually happen, given that each node only has 1/8.
Yeah, so the parts are gossiped on the network, so you can request any part that you want as long as it's available and the nodes will serve it to you. You have this feature of like erasure coding. That means that if you have like sufficient parts of the data that you want, like you can reconstruct it locally, and you don't need to like get especially like the unique parts of the blobs that you are like looking for. And so yeah, it's basically based on this. So like having networking that allows like the separation of these blobs and the dissemination of these parts of blobs, and then the erasure coding to reconstruct the data locally.
But was this feasible before? Like, why? What has changed that suddenly this is happening in this upgrade or in
And
Fusaka?
you need to implement it. So yeah,
Okay.
that's what changes. Yeah, and
Okay.
I think it's a little bit easier to say that. Yeah, your node locally can convince yourself that the full block is available if it has every part of the block. It's kind of a paradigm change to say that now you will vote on the availability of a block like without having seen it fully yourself. So yeah, it's just implementation, which is costly.